Well, good afternoon. It is good to be with you. Everybody having a good day today?
Yes.
You learning lots of cool stuff? How many of you been over to see Atlantis? All right. Just a remark, that's my airplane over there. I just want you to know. I let them borrow it so that you guys can look at it. Besides, it doesn't fit in my garage anyway. Well, what we're going to do today, I've got a little video I'm going to share with you, and then we're going to have some time for some Q&A. And what I'm going to do is talk about, in my lecture part, I'm going to talk about the answer to the question I get asked the most, which is simply, what is it like to fly in space? So before I do that, how many of you would like to fly in space someday? Raise your hand. Good. We got a bunch of guys. You guys from doing the space camp thing? Is that what you're doing? Yeah. All right. Welcome. Good to have you here. How many of you know somebody you'd like to send to space? I think I got more hands on that one than the first question. That's round trip or one way?
One way.
One way. Okay. Well, what we're going to do is, as I mentioned, I've got a video that's going to talk about what it was like for me and others to fly in space. But before I get to that, I have a lot of fun, and I hope you will too, to first of all kind of prepare you for that. And the way I'm going to do that is, if you're up for it, is I'm going to describe some events and have you imagine yourselves going through those events and getting ready for launch and launching and being in orbit. You up for that? Yeah. Sound good? So now also, in the video, I've got 4 words that I use to just kind of summarize my experience. And what I'd like you to do when you're imagining yourselves going through this experience is to think of words that you might use to describe what it would be for you. Because I like collecting these words because usually they're better than mine, and so we can do that afterwards. Okay, so let's get going here. Now, my experience was flying on the space shuttle. I flew twice on the shuttle back in 1988 and 1990. You kids in space camp, you remember those years, don't you? Maybe not. Okay, but I remember it well, and so I'm going to talk about my space shuttle experience. It's pretty much the same today with the crew capsules, and where it's different, I'll kind of point out those differences. So let's get going. Okay, imagine yourselves getting ready to launch. First thing, you're going to put your pressure suit on. They're heavy, hot, bulky, not particularly comfortable, but they're designed to protect you in case a variety of things go wrong. There's the first difference, is our shuttle pressure suits were orange. Today they're white, with the black boot-looking things on their feet, and I think they're much cooler looking today, but they're designed to do the same thing. Now you get your pressure suit on, got your helmet on, you got your earphones so you can listen to your crewmates and launch control. You actually have two mics for redundancy so that you can talk to them as well. Then get strapped in your seat. Get strapped in real tight. It's kind of like our younger grandkids have the little car seats in the back seat where you got the buckle in the middle, strap around each way, strap around both shoulders, even the strap up between your legs so you're hooked in nice and tight. Don't want to fall out during launch. And then you're not sitting the way you are here today. Now the space shuttle was like an airplane. It landed, actually a glider. And so you were sitting up for landing, but for launch, of course, it was tilted back on its tail. So you're lying on your back, on your parachute, on the back of the seat behind you. Capsules, the same thing, lying on your back both for launch and for landing in the crew capsules. Today, as well as back in the Apollo, Gemini, Mercury era as well. So that's the big difference. So there you are. In your suit, strapped in really tight, lying on your back. Everybody there? Yep. Okay. Now I want you to imagine that your seat is bolted down to 4 million pounds of high explosive rocket fuel. And somebody lights the fuse. And you know you're going somewhere and you're going to get there really fast. When they light the solid boosters on the shuttle or the jet engine, rocket engines out here on the pad today, there's a lot of noise and vibration and shaking, and you are pushed back into your seat from the acceleration of those rocket engines. The space shuttle's thrust was about 7 million pounds of rocket engine thrust. Now the forces you feel, we talk about those in terms of the force of gravity, which we abbreviate with the letter G. So right now, we're all experiencing 1G that's keeping you in your seats and me on the floor up here in front of you. So on launch, the shuttle actually only reached a maximum of 3 Gs during launch. It was a big airplane with wings. It carries sensitive instruments like satellites and other experiments in the back end. And NASA wanted to minimize the launch forces as much as possible so you didn't have to over-design your experiments and stuff. Now we're just launching people, and so in the rockets, they actually have about experience 4.5 to 5 Gs during launch, because that's a more efficient way to get up into Earth orbit. But the experience is pretty much the same as you're squished back into your seat. So there you are, you blast off. Imagine what that would be like for you. Shake, rattle, and rolling as you head up, as you leave the planet surface, and you go up in about a minute or less. You watch, if you peek out the window, you can see the Earth sky go from blue to black. You continue to accelerate. Now the space shuttle had 2 solid boosters, and at 2 minutes they ran out of fuel and were dropped off. And you continue to burn as you head up, in a total of about 8.5 minutes from sitting on the pad to getting to where you accelerate to your orbital speed of 17,500 miles an hour. It's about 5 miles a second. Think how quickly you could have gotten out here today at 5 miles a second. Wouldn't that have been nice? Of course, you got to worry about stopping. So anyway, 17,500 miles an hour. So imagine what that would be like for you to experience a rocket launch, and what words you might use. Now, when you hit 17,500, your engine shut down, you instantly go from that 3 Gs or 4.5 Gs to 0 Gs of force, and you are now weightless. So imagine what it would be like to be weightless. You're walking around here all day today, kind of nice to sit down and relax a bit. Think if you could just float, what would that be like? I call it the, now back in the 1980s, there was an Olympic gymnast named Mary Lou Retton, who was, I think she got the first 10 in an Olympic gymnastics event. And so I call it the Mary Lou Retton Eat Your Heart Out experience. Now today, I probably could call it the Simone Biles Eat Your Heart Out experience, after her performances the last couple of Olympics. So anyway, you do all kinds of flips and tumbles and stuff that I can't do down here on the surface of the planet. So imagine what it'd be like to be weightless and what words you would use. Okay, finally, third thing, you're up in orbit, 17,500 miles an hour. You're about 250 to 300 miles up above the surface of the planet. You're weightless, and you float over to the window and look at the Earth going by below. Imagine what that would be like. Now, it's not that little blue ball in the blackness of space. You've all seen pictures of that. That's what the astronauts coming back from the moon got to see. Instead, you're only up about 250 miles above this 8,000 mile diameter planet. So if the Earth were a basketball, you'd just be maybe 1/4 inch or less above it. So it fills your field of view. You look out the horizon, you can see the curvature of the Earth out there about 2,000 miles away, and the thin blue bands of the Earth's atmosphere that protect us from outer space. When you look down, you can watch the oceans and the continents going by below. You circle the Earth every 90 minutes. Every hour and a half, you go completely around the planet as it's rotating underneath you. So you get to see the whole Earth in the course of your day as it rotates around below you. The oceans and the land masses, they're not the classic blue water and brown or green land mass. They are a wide variety of different colors and hues, and even textures are different. One desert, for example, will look different than another desert. So imagine what that would be like looking at the Earth from space. And what words might you use to describe that? So now we're at that point where I'd like for you to participate a little bit. And anybody have a word you might use you'd like to volunteer? Anybody? Right here, this young man. Incredible. Yes, that's a great word. Wow, that's much better than my words. Okay, anybody else got a word? Raise your hand. Right here, this young man. Awesome. That's a great word. I'll see that again. Yeah. Amazing. You guys got great words. Okay, right here. What? I'm sorry. Undescribable. Yes, I'm doing my best, but it is undescribable. Okay, anybody else has a hand right here? A couple of hands. Astonishing, and what's the other one? Cool. I like that word. That's what my kids and grandkids know that that's one of my favorite words. Of course, I'm from another generation. So, another word. We'll just do one or two more if you've got them. Way back up here, yeah. Yell it out louder. Crazy. Yeah, that's a great word. And then there's one over here. What is that? Stupendous. Man, you all got great words. We're going to go to my words now in the video, but before I do, I know you've all got a word. So on the count of three, I want everybody to shout out your word at the same time. Ready? 1, 2, 3. Great, I need to. Okay, we're going to go to the video next. Now, in the video, I've got 4 words that are going to pop up on the screen. So when they do, what I'd like for you to do is all together shout those words out. Okay, can you do that? All right, good. And by the way, as Nick mentioned, I've most recently been serving as a high school math and physics teacher, and so I've got to give a quiz. So at the end, we'll have a quiz on those 4 words, but it'll be easy. We'll just do it all together. Okay, so Sarah, if we can get the video rolling, we'll cover that. We're going to start with actually my second launch back in 1990. There's that young guy there with the bald head and mustache. And this was a night launch. And we are calling the hatch. I was the PLT, or the pilot on my missions. So the last thing I do is start the APUs, which power the hydraulic system for the gimbling of the engine. So here we're going to check those gimbling out before we launch. Everything looks good. Now 7 seconds before T0, we light the 3 main engines. And the computers check them out, make sure everything's running properly. And then at T0, we light the solid boosters, and away we go. So imagine what this would be like for you to launch. It's really cool at night because it really lights up the sky even more in the daytime. Now, we even had a little cloud deck up there about 10,000 feet. It was really cool to fly through that. See, I'm using that cool word. Fly through that cloud deck because it really lit up the sky around us. Because in the cockpit, we don't see all this fire going on. Now, you notice it's easy to see the solid rocket booster exhaust, but the 3 main engines, looks like nothing's coming out. They're just lit up because they're burning the fuel in the big orange tank, liquid oxygen, liquid hydrogen, which come together to form water. So it's just steam coming out. After 2 minutes, as I mentioned, the solids come off, they had parakeets that came out, they floated down and were recovered out there in the ventilation and used again. Meanwhile, we continue to burn the 3 mains for a total of 8.5 minutes, accelerating to 17,500 miles an hour. Okay, we're going to go to my first launch now. It was an early morning launch, but we headed out there, it's still dark. There's that young guy again there in the back. Looks like orange gummies here. Those of you who know. Okay, here we are. 7 seconds to T0. We light the 3 main engines. It's a big cloud of steam. And off we go. You can see us waving to the cameras here. Oh, maybe not. Okay, here comes my first word. It is exciting to ride a rocket. And here's my word for being weightless. It is fun. It's a lot of fun being weightless. Now, this is Luke Gibson, commanded my first mission. We're imitating that old Fred Astaire movie from the 1930s where he dances around on the floor. By the way, I recommend you not try this at home, okay? Jerry is going to give it a go. Jerry, by the way, was the first person to fly 7 times in space. And so far, only Jerry and another one of my astronaut group classmates, Franklin Chengias, have done this. So they had a great ending here. Ta-da! Okay, it's my turn. And who says my legs are just too long for this sort of thing? And if you look in the upper left corner, you see a little wire. I get all tangled up in it. So here are a couple of aileron rolls to finish it off. By the way, the thing I'm grabbing there was my Sony Walkman.
2-1 now to Bagwell. 34 home runs, 111 runs. 1 of 11 in the series.
This is peanut M&M baseball. Of course, the object is to catch it in your mouth. And I think I was safe. Jerry uses hands. Okay, here's my changeup pitch to Jerry. There's the old, you've heard of the line drive to the pitcher. Boom. Okay, we did have a real football on board. Here's the opening kickoff to Hoot. He gets it. He sees all the tacklers coming after him. And he's out of there. He's off to Crazy Legs Mike. And here they come. By the way, this is your tax dollars at work. Okay, here's the big play. We're going to send Mike out for a long pass. Touchdown! By the way, that was an NFL record at 5 miles a second. That was a 15-mile pass. Here's the kick for the extra point to win the game. And it's good! Here's Greg in the slam dunk contest. See the little orange ball he's got in his hands? On the left side of the screen, you can see the little hoop. Well, let's see if he can put it in there and dunk it. Oh, he's going around again. All right. What I want to do now is talk about actually living in a weightless environment. Of course, we have to eat. And a lot of the foods that we took up then and they use today are dehydrated to save both weight and space. And so you get up there, you have to have water. That's some rice that Kathy has in her hand there. She's putting in the little water adding machine, they call it that. This is some unidentifiable vegetable that's floating there. Now, the little black knob selects the amount of water. Each food thing will tell you how much to use. And we had a little, we called it an oven, but it really just circulated warm air around the food to keep it warm while soaking up the water, or to warm up those foods that do not require rehydration. This is a hamburger patty she has. And the yellow button has hot water, and the blue button has cold water. You might want to fix a cold drink. Here Mike is fixing an orange drink. And now if you just had a glass of orange juice out in a regular, like we do down here, you can imagine what would happen as it went around all over the place. So we even had not only a container to contain it, but a special straw with a clamp on it. That's because without the clamp, the liquid will actually crawl right out of the straw and go all over the place. So undo the clamp, take your drink, and clamp it back up. Each meal, variety of packages of food and drinks. We had a little tray that would keep them all in one place and not all floating around. We took other foods up like tortillas. And here Ron is fixing himself up. Of course, astronauts love to play with their food just like you do. And here Kathy and Charlie are gobbling up M&Ms. One of our favorite foods to play with in space, that along with those goldfish crackers. Get that last one, Charlie. All right. Here I am with a spoonful of pudding. And here's Anna gobbling up M&Ms. Here's a water bubble that's loose down on the mid-deck. Now, the surface tension is what causes it to form a sphere or a ball. And when Jeff comes along to suck it up, well, it also makes it crawl right up his nose. Here Jeff and Sam each have a water bubble. Kind of fun to watch them come together. Now, what else can we do with a water bubble? That's how you take a shower. Well, when we get up in the morning, we got to get ready for work, just like down here on the planet. Here's my shaving. We had either electric or blade. Both had advantages and disadvantages. And here I am floating down to brush my teeth. We had a little hose we hooked up to the pressurized water supply, and then squirt some water in your mouth and brush your teeth just like you do normally down here. The big difference is we didn't have a sink into which to spit the toothpaste, so we had to use an old washcloth or towel or something. And here's our space potty. You can see the schematics on the left side and the procedures, but it's actually pretty simple. It's like an outhouse arrangement with special airflow to make sure that everything goes where you want it to go and then it stays there. Our form of exercise was the treadmill. They have this on the station now, along with a lot of other exercise equipment. Notice Charlie has a harness around his shoulders and waist and then bungee cords to keep him attached to the treadmill. Without that, when he tried to take a step, he would just go floating away. We use this primarily for maintaining bone strength as well as muscle strength. It's use it or lose it. And so we have to keep those bones stimulated. Now, we didn't have a shower or bathtub on the shuttle or the station, so you take what we call a sponge bath. Just soak yourself down, rinse off with a clean washcloth, as you see Mike doing here. He's using the hot water from the water dispenser. When you want to go to sleep, just relax, close your eyes, and go to sleep, because you're weightless. But we did take sleeping bags up. You can see Shep has his hooked to the wall. You can hook them wherever you want. They not only keep you from drifting around, bumping into things at night, but also they give you that feeling you're used to of the sheets on top of you and the bed underneath you. Okay, here's my fourth word. It is meaningful. Yeah, we don't want to spend all those tax dollars just having fun and excitement. Now, my first mission was a classified mission for the Department of Defense, so I can't really tell you about that mission. Or as the old joke goes, I can tell you, but I'd have to kill you, so I won't tell you. I can tell you we deployed a satellite on that mission. You'll just have to figure out what it might have been used for. My second mission, though, is an astronomy mission. There's an X-ray telescope right here. And in front, to the right of that, here they are deployed, is a set of 3 ultraviolet telescopes. And we use those to get them up above the Earth's atmosphere, study the universe around us, and then we brought them back home. They weren't self-sustaining like the Hubble Space Telescope is in orbit. What the shuttle's been used for its last 13 years was building the space station. So here we have it. It's actually larger than either a football field or a soccer field, both in length and width. In the middle are the modules where the crew lives and does all their experiments, the laboratory modules. Out on the ends are the solar arrays that collect the sun's energy to power the station. And yet the white-looking panels are actually radiators that are used to radiate the heat generated back out into deep space. And astronauts have been continuously up there for a long time, probably 20 plus years. Of course, what we do in our spare time is we float to the window and look at the Earth below, and my word for that? Awesome. It is, there you go, it's awesomely awesome to look at the Earth from space. Here's some pictures that I and other astronauts have taken. Greenland and the North Atlantic, you can see the fjords and the ice pack in the middle. Eastern Mediterranean, notice how the Nile River Delta, the vegetation really stands out from the desert around it. Over on the right, of course, is Israel, Lebanon, Turkey at the top. Looking back across the Sinai Peninsula and the Red Sea, Moses did some walking around a few years ago. When the sun's at just the right angle, it really makes the water features pop. You can see the Nile River there on the top of the Red Sea. The cradle of civilization, the Tigris and Euphrates rivers, where the country of Iraq is today. Highest mountains on the planet, Himalaya Mountains. You can see India down below, and the Tibetan Plateau up above. Further east over the Pacific Ocean, these are atolls. That's Bora Bora there on the right. Further east are the Galapagos Islands, kind of come together to form the shape of a seahorse. You can see on the left where it looks like he's been drinking some milk. This is an active volcano in Japan. Down at the bottom, that's what cities look like from space, just kind of gray blotches. Coast of Alaska, there's a glacier there in the lower right flowing down into the ocean. Over Southern California, looking into Mexico, you can see the Gulf of California, Baja California. Down here at the bottom is the Salton Sea. This is a hurricane. This one's out over the Gulf of Mexico. You can see the eye of the storm there in the middle. We're going to take a little trip up the Mississippi. This is where it flows into the Gulf and the Delta. At the top is New Orleans. Further north is Memphis, Tennessee. I use this to show you can see man-made objects from space besides the Great Wall of China. That's the airport there, kind of the lower right section. You see the interstate stuff. Great Lakes, the United States and Canada. Lake Michigan in the middle with Chicago at the bottom of it. Further east, Detroit, where you can see the Niagara River. We're connecting the two lakes with Niagara Falls and the Delta. Long Island, New York. Over on the left side is New York City. There's Manhattan. Our oldest grandson's going to college right now. East coast of the U.S., I took this over Lake Erie. You can see the Chesapeake Bay there and Delaware Bay in the middle, Long Island's up on the left. It's the Shenandoah Valley going through the middle. Thunderstorms at sunset over the Pacific Ocean, much more beautiful in person than come across here. Of course, sunsets are spectacular from orbit. I think they're spectacular down here too, but they're different. We're going around the Earth every hour and a half, and so the sun sets much more quickly than it does down here. This is real time. I didn't speed this up. You can see the bands of blue in the atmosphere I mentioned. And the cool thing is you watch a beautiful sunset like this, 45 minutes later, you get a beautiful sunrise. 45 minutes later, another beautiful sunset. That's actually one of the harder things about flying in space, is getting up in the morning, and then 45 minutes later, you gotta go back to bed again. 45 minutes. No, we obviously don't use the sun for our daily schedule. Well, each crew designs a patch for their mission. And so my first flight, we were the second mission after the Challenger explosion of '86. So we have 7 stars to commemorate the crew that died. And of course, the rainbow represents God's promise of the new beginning. My second flight, astronomy mission called Astronaut. We have the constellation Orion, one of our astronomy astronauts' favorite. And that's the video. Thank you. Okay, I promised you something, didn't I? A quiz. So let's go over those 4 words together. Okay, we'll make it easy. Okay, so what's the word for riding a rocket? Exciting. Exciting, that's correct. Can we sound a little more excited than that? Okay, what's the word for riding a rocket? There you go, excellent. What's the word for being weightless? For doing good work? Meaningful, that's the hard one. And for looking at the Earth from space? Awesome. You guys are awesome. We got a really loud cheering group up here. Okay, what I'd like to do now before we get to Q&A is we've talked about being weightless in space. So I've got a question for the group, and that is simply, all shout out the answer together. Why are you weightless in space? Okay, a lot of no gravities, and some of that I think the correct answer. So let's think for a second. The space station is up there in orbit around the Earth going 17,500 miles an hour. What would happen to it if it didn't feel the Earth's gravity? It would go zinging off into the universe, wouldn't it? So there is gravity in space. That's what holds the universe together, okay? Matter of fact, I won't go into all the orbital mechanics of it, but that's the magic number of 17,500 is that you're zinging off the universe, but it perfectly balances the fact you're falling towards the Earth due to the Earth's gravity. And so as you go zinging off, you're falling, zinging off, falling, zinging off, falling, and that keeps you in that circular orbit. Go a little faster, you go out higher away from the Earth. Go fast enough, you won't even come back. That's about 25,000 miles an hour. So if you want to come home, that's what we do. We just slow down a little bit. Now we're going to fall a little bit faster, then we're zinging off. And then so our orbit's going to drop down into the Earth's atmosphere where it's thick enough that it will continue to slow us down and we can come back home and land. So why are we weightless in space? It's because we're falling. That's what makes you weightless. So what I'd like to do is a little demo. How many of you have been weightless before? Okay, I think you all have, but I've got a little demo. So anybody want to volunteer to come down here and do a demo? I usually grab one of the, okay, why don't you come down? Oh, can you get by you? There you go. We normally do this over in the Universal Theater, but they're upgrading the sound system, so we're in here this morning, which gives us a little more room, but it makes it a little harder to get down to the front. What's your name? Okay, you ready? Want to be weightless? Okay, let's do this together. Stand beside me and bend your knees like this. Okay, on the count of 3, we're both going to straighten our legs real fast so we jump up in the air. You ready? 1, 2, 3. We're weightless, we're not. You're weightless whenever you're falling. Is when something is preventing us from continuing to fall down to the center of the Earth, is when we weigh something. We weigh something on the platform here. You weigh something sitting in your stairs. but it's not very long to enjoy it like we do in space. You want me to wait just a little longer? Okay, I'm going to take a little risk here. You're pretty nimble, yeah? Okay, so what I want you to do is put your feet up here, okay? And I can help you if you want, or you stand on the arms of that chair. It's easier over in the other theater. I've got some steps. Okay, on the count of 3, you're going to jump down to the floor. You ready? 1, 2, 3. You're weightless, astronaut. Okay, let's get it. Thank you. So you've all been weightless before, okay? It's whenever you're falling. Now, if you get on a trampoline or jump off a high dive, you get to experience a little longer weightless. Or if you go into low Earth orbit, you get to experience weightless a long time, as long as you're going 17,500 miles an hour in low Earth orbit. The moon's actually going a little bit slower than that. It's taking a longer time to get around. But if it weren't, the moon itself is weightless, but if you're standing on the moon, you're going to feel the moon's gravity holding you down there, and you won't be weightless on about 1/6 of your normal weight. Okay, so you're weightless because you're falling. Now, one other thing I want to kind of chat with you about before we get to the Q&A, and that is, the shuttle was built with a purpose in mind. And its purpose was to get into Earth orbit and do whatever that individual mission is involved to achieve its purpose. My first flight, as I mentioned, was a classified mission that put a satellite out. My second one was to study the universe with these scientific telescopes. Okay, I think that each one of us also has a purpose, or purposes probably act more accurately, in life. And so the shuttle, in order to achieve its purpose, needs a lot of stuff, but I summarize with 3 things. 1, it needs speed. It needs to get going that fast, 17,500 miles an hour, in order to get up into orbit. Number 2 is it needs gravity. Remember, without gravity, it wouldn't stay in orbit. So it needs gravity in order to stay in orbit to do its mission. And number 3, it needs a good guidance system. It doesn't do it any good to be going 17,500 miles an hour pointed straight down to the Earth. Okay, the mission wouldn't last very long. So it needs a good guidance system to make sure it gets up there and stays in the right place and does the right things. So I relate that to our own individual lives. I like to do this. The first thing I think that goes along with that speed is knowledge, learning, education. We need to learn the things we need to know to go to the places we want to go, right? Makes sense. So my encouragement is for each of us, and not just the young kids in here, but all of us, is that we be excited about learning. Learning new things all throughout your life, because that enables you to do more things to achieve your purpose in life. Number 2, this one's kind of hard to understand my correlation, but it's integrity. It's also hard to define integrity. Not only means that you tell the truth all the time, but it means you can be counted on to keep your word. If I have integrity, tell you I'm going to do something, you can count on me either doing it or certainly trying my best to make it happen. So it needs integrity. Now, how is that like gravity? Well, as I mentioned, gravity is what holds the universe together. So I want you to imagine a very close friend, or person you have a very close relationship with. It could be a close friend, it could be a parent, it could be a sibling, it could be a spouse, whatever it is, it could be a child. But imagine that relationship, and now what would happen to that relationship if you couldn't trust the other person? The other person did not have integrity. It would come apart, wouldn't it? And I think that's true not only for one-on-one relationships, I think it's true for groups of people, and even whole societies. Without integrity, it'll come apart. Might take a little longer than the universe coming apart if we could magically shut off gravity, but I think it'll happen. And the third thing that goes along with that guidance system on the shuttle, we need good guidance systems. We need to make sure we have some kind of moral compass that's keeping us pointed in the right direction. There's many ways to do that, but you want to be pointed in the right direction so that you're achieving your purpose in life and helping to make this world a better place for everybody. Okay? So, and then the result of that is your lives will be those same 4 words. They'll be exciting, fun, meaningful, and just plain awesome. Okay, we got time for Q&A here, Nick?
Yeah, we have time for some questions. If you have a question, feel free to raise your hand and then just call it out. So let's see those hands. Who's going to be first? Young man right there with the hand in the center. Yes. How long were you in space, guys?
How long was I in space? I was 4 days on my first flight, 4.5 days. Just had to get that satellite out on the first day, hang around for a couple of days to make sure everything was working right, and then we came home. Second flight was 9 days, supposed to have been 10 days, but we ran out of toilet paper and had to come home. Actually, they brought us home, Mission Control brought us home a day early because the weather for landing was forecast to be bad both on the 10th day and the 11th day because we couldn't extend it a day. So they brought us home a day early. But we were running out of toilet paper, so we were happy to come home. We were the first 7-person crew for a 10-day mission, and with all the incredible planning that NASA does, they failed to add an extra complement of toilet paper for us on that flight. And we kept looking for a grocery store or something like that to get some more, but couldn't find one.
Okay, young man, that right there. You, yeah.
So the rocket that you were on, did the rocket like land like an airplane? Like, how did it come down? Did it just go straight down from space? I'm like,
Yeah, no, when you come back from, the question was how do you get home? You know, do you come straight down or how do you do that? And so the shuttle was an airplane, it landed like an airplane as I mentioned. Oh, here we are.
There to the right.
Over to the right, we're going to come and land here in the Kennedy Space Center. And so you actually, I don't have it in the video, I just can't do everything. You have to turn around, slow down, fire your little jet engines, slow down a couple hundred miles an hour on the other side of the planet. And then that orbit will bring you around the Earth. As you keep coming down, you'll start getting thicker atmosphere. You'll feel those deceleration forces that feel like gravity here, up to 1.5 times the force of gravity. And then as you get over the field, the shuttle, since it landed like an airplane. Now the capsules today, they do the same thing, but as they get down into the thick atmosphere, when there's several tens of thousands of feet above the Earth, they deploy parachutes, and then they float down either into the ocean or on the land, depending on which capsule you're in. The shuttle landed like a plane, so as you got down, you would actually fly a little teardrop pattern over the air, around the airfield, come in. You're a glider that doesn't glide very well. So we actually would roll out on final instead of a normal airplane that rolls. Isn't Sarah awesome? She does such a great job running the. It's Sarah today, right?
Yeah, that's wrong for Sarah.
Let's get Sarah on. I talk about something, the next thing I know, there's a picture of it behind me. Where was I? Oh, so you roll out on final at about 12,000 feet above the ground. Normal airplane pattern altitude is 1,500 to 2,000 feet. And you're on a 20-degree glide path going 300 miles an hour instead of on a 3-degree glide path going 140 miles an hour. And then you're aimed short of the runway, and then when you get down to about 1,800 feet, normal pattern altitude, you pull the nose up, and since you're a glider, as soon as you do, you start slowing down. And I'm missing all the good stuff. You start slowing down, and it's all timed so that you slow down to around 200 miles an hour, about 1,500 feet down the runway, and touch down. You don't lower the gear until you're in that, what we call pre-flare. You know, a normal plane, lowest gear, way out of final. And the reason is because that adds to the drag. And it's going to slow you down faster. And why do you wait so long? What if they don't come down? You're going to land anyway. And it gives you less time to worry about it, you know. So.
Let's take a couple more questions right over here.
were you scared when you were like blasting?
Was I scared when I was blasting off? I get that sometimes. The word I get when I ask for words will be scared or terrified and that sort of thing. I was not. And let me give you some reasons why. I got 4 reasons here. One, I had lived a life with probably a little more risk in it than most average folks do. I flew combat in Vietnam. I was a test pilot. I drove a car in New York City and Manila. So a lot more risk than probably average. Number 2, I had, as I mentioned, the second flight after Challenger, I had, did I mention that here? Anyway, I was the second flight, oh yeah, in the patch. So I had literally thousands of people working their best to make sure my flight was as safe as practical. Okay, so I can trust all these hardworking people to be doing their job. Number 3 is I was the pilot astronaut, and as such, mentally, I'm very busy. Now, if everything goes right during the shuttle launch, I wouldn't do anything. The computers take over just before you light the main engines, and they keep in control until you get off, shut the engines down, get off the external tank. But We have trained literally thousands of hours in the simulators in case something goes wrong. Because if something goes wrong, I need to respond immediately and get switches reconfigured or, computer inputs to get things back in a safe configuration. So mentally, I'm very busy. Now, that's not to say the mission specialist down in the mid-deck with no windows to look out, with nothing to do, and having to trust the crazy pilot upstairs to do the right thing. That's not to say that wouldn't be one of his or her words. So, the fourth thing finally is I'm a man of faith, and I was where I thought God wanted me to be, and what better place to be than that, even if things go wrong. Okay, so scared's not one of them.
Okay, we got,
Thank you. Thank you.
we got the last question right there, young man in the hat.
If you, would it hurt if you fell on the moon on your back?
Would it hurt if you fell while you're up in orbit?
No, on the moon.
Oh, on the moon? It wouldn't hurt as much. And we actually Nick's my guy for trivia. And didn't one of the guys fall down?
We had an incident where Charlie Duke was supposed to be doing this, seeing how high he could jump. And on the second jump, he misjudged his push and the weight of his backpack carried him backwards, and he landed on his backpack, which is a very dangerous thing because it was a delicate piece of hardware, but everything was all right. And John Young, who was with him, typical John Young, looked down and said, "That wasn't a smart thing to do, Charlie."
But it didn't hurt him.
No.
He was fine. So just think you're one. So how much do you weigh now?
60 or 50.
We go with
About
60.
60 pounds.
60 pounds, good number because it's easy to divide by 6.
Right.
So it'd be like you only weighed 10 pounds and you fell down, which would be pretty light, right? So it wouldn't hurt as much.
We're there.
Okay, well, let me close up with thanks. Great being with you all today. And so in closing, let's go over those 4 words again. You ready? What's the word for riding a rocket? The big weightless. Doing good work? And looking at the Earth from space? You guys are awesome. And that's my wish for you. Oh, thank you. Thank you. May you have lives that are those 4 words, whatever you do. You obviously don't need to go to space to have a life that's like that. And I wish that your lives are exciting, fun, meaningful. You'll be doing good things to helping other people on our planet, and just plain awesome. God bless you. Thank you very much. Have a wonderful day here at the Kennedy Space Center.